Welcome to this lecture on the discovery phase of biomimicry thinking. By now you should have completed the scoping phase and have a good idea of what problem you're trying to solve, as well as the context in which it resides. In this presentation, we will discuss the three major aspects of abstracting a design principle from a biological model: the function, strategy, and mechanism. We are now in the discovery phase of the biomimicry thinking process. Once we've discovered our biological models, we need to identify the function, strategy, and mechanism. Understanding these three terms is essential to the process of biomimicry thinking because they are at the core of how we emulate nature in our biomimicry design. For this process, we introduce you to the steps required to analyze natural models in the discovery phase. The overview of all three steps includes the function. What does the natural model do? Secondly, the strategy. How does it do that function? And finally, mechanism. How the strategy works in detail. We've made up an activity card deck that you will be using to fill out afterwards, after the brief lecture. Right now, we're going to get some practice understanding the role a function plays in an organism's life. We'll start by looking at an adaptation in nature and try to discern what some of its functions are. Let's take a look at zebra stripes for an example. Here's the example worksheet we will fill out together as a group, step by step. So to start with, let's quickly define what a function is. Put simply, a function is what an organism does. This can be summed up as an action or a trait that helps an organism to survive. It could be as simple as move, protect, or capture, but it's often more complex than a one-word descriptor. Much like the functions discussed in the scoping phase, it's important to be specific about what the function is in order to develop a list of model organisms that are relevant to what we want our design to do. This allows us to narrow our focus while still keeping an open mind when looking for potential champions during the discovery process. For a practical example, let's say you're tasked with the challenge of building a better box for storing and shipping fragile objects. The natural world does not build boxes, but it does protect. So we can start with a base function of protect from physical harm, but that on its own is not very helpful in creating a list of potential organisms because nature protects from all sorts of things. What do we want to protect from? Dirt, bacteria, predators, being crushed? So we can further define our function by using the biomimicry taxonomy tool and define that we want to protect from external forces, and then go to the next subgroup to further define the challenge. Narrowing the function gives a good foundation to start looking for appropriate biological models. So let's follow the example of the plain zebra. What is their mechanism? How do they solve their challenge? Recent studies have shown that the pattern helps protect from predators in a different way than traditional camouflage does. The stripes on a zebra's flank are an example of what is known as dazzle pattern. This means that when the zebra is moving, the bright contrast between the stripes makes it difficult to gauge the speed and direction. The zebra uses this ability with its natural herd instincts. So when the entire herd runs away from a predator, the stripes make it difficult for the predator to stalk and hunt them. So the function we can extract from reading this mechanism is camouflage in motion. After defining function, we next look at the strategy. The strategy is a short summary of how an organism achieves a specific function. We determine this by looking at a specific adaptation or trait that is present in the organism that helps it manage a challenge. These strategies are often different because the context in which the function is being performed differs. Going back to the earlier example of protect from external forces, we see that there are a variety of ways that this is done in nature. A woodpecker protects itself differently than a mussel would, and both are different from a coconut. Each one uses a different method to essentially do the same thing because of the immediate needs of that organism. Understanding the strategy in which an organism lives and performs is helpful in understanding the biomimicry application in your design. So the strategy here is the zebra uses its stripes to create optical illusions while moving that confuse predators, protecting it from harm. The final part is the mechanism. The mechanism is the detailed explanation of how a strategy works. While a strategy will give you a broad idea of how a function works, the mechanism will give you critical information needed to expand on the idea and abstract a design principle, such as scale, temperature range, and chemical names. Understanding the mechanism is the most important part of a successful biomimicry because the mechanism is the part of the organism that we are trying to emulate. We can get information about the mechanism from a variety of sources, but the most helpful is from a biologist or from primary scientific literature from journals. While some secondary literature can have information regarding the mechanism, it may be distilled and lack some critical components because it emanates from journal summaries. The mechanism information is important to have, as it's a significant part in abstracting a good design principle, which we will be discussing in a later lecture. While we have provided the mechanisms for you to distill the function and strategies from, if you were to start this process on your own from your discovery research, you would be doing the research and learning more detail about how the mechanism works and fill in the top section. Also, this is a great time to brainstorm what applications this function strategy could be used for in human design and fill that out in the applications section below. So next, we'll look at another example to get some practice understanding the role a function plays in an organism's life. We're going to start by looking at an adaptation in nature and work as a team to try to discern what some of its functions are. This organism is one you may be familiar with, the cactus. Now, while the cactus has several adaptations, we're going to be focusing on the spines. We've given you the mechanism from scientific research up above, and now we want you to take a few minutes, pause the video, and write down what functions these adaptations serve. With this example of the cactus, many people would probably look at them and automatically assume that the spines serve as a form of predatory defense, and they would be correct. But it's important to remember that nature uses multifunctional design, so these spines also serve additional purposes. Spines are a means of self-shading the body of the cactus, which helps with both preventing water loss and managing the heat from the desert environment. So we can add protect from extreme heat as a second function. The spines also can help condense water from fog, giving them a third function of collect water. So if we wanted to write a strategy for the function the spines play in protect from extreme heat, how would you write that? Pause the video now and take a couple of minutes to think about it and discuss it as a group. Now that you've had time to discuss possible ways of describing a strategy, let's look at what's happening and come up with a single, concise answer. The spines shade areas of cactus skin and lower the surface temperature of the cactus's body. This lower temperature means the cactus suffers less water loss, which allows it to thrive in the desert harsh environment. So a good way to summarize this strategy would be to say, the cactus uses its spines to condense and absorb water and to provide shade, which helps protect it from extreme heat conditions. So lastly, as a team, brainstorm some applications for using this strategy in human design and fill that in the bottom of the form. So to wrap this all up, we're going to do an activity to give you some more practice breaking down biological information into its functions and strategies. For this activity, you will choose an organism discovery card to fill in. Here are the cards you can choose from. You could choose the fennec fox. The mechanism is all filled out for you. You just need to find the functions and the strategy and applications. Or you could choose to look at the darkling beetle. The Venus flower basket is a beautiful structure to work with. Or learn more about the color of the blue morpho butterfly. The last natural model we have for you to look at is the whale, particularly its fin and form and mechanism. Next, we'll break out individually or into groups for this exercise. You should all now have a biomimicry discovery card in front of you. Read the mechanism on your discovery card and use that information to fill in the function and strategy boxes. Once you fill those in, try and think of some possible applications these strategies could have in human design. When everyone is finished, we'll come back together for a group discussion and wrap up. Have fun with this.